Happy New Year, everybody. Hope everybody had a good holiday season. It's been quite a while since I've recorded one of these practice models, so jumping right back into it. Things were a little slow first time around, 4 minutes and 15 seconds roughly to solve this part first time around. So I'm going to change up my setup and the structure in which I make these videos. So we'll do one speed run and then one full solve together. Hopefully that'll give a little bit of perspective from both sides. So let's go ahead and start this print. We'll start a millimeter part and go ahead and start a sketch on our front plane. My approach here, since this is a uniform thickness part, is going to be to draw out just a shape that looks like this. I'm going to convert these two lines to construction geometry, and what we're going to do is we're going to make this a thin feature revolve. So I'm just going to draw one of the walls, and then from there it'll be like revolving a surface and thickening it the 9 millimeters that we need for in this case. So it ends up being a little bit tricky, but we'll start by finding this one diameter dimension in the corner of the print, which is 180. Then we set our overall height to be 195. This angle dimension here is a little bit tricky to find as well. It's 13 degrees between the two walls, so we're going to divide it by 2. Then we are looking at the overall diameter dimension here, which is going to be 85 millimeters, and that defines our wall thickness here. This bit here is going to be our central circular cutout, so 21 millimeters, and then the last dimension that we need is just this height here, which is going to be 20 millimeters. So there we go, we have a fully defined sketch, and this is again just going to be the inside wall in this case. And that reminds me, because it's the inside wall, I need to subtract the wall thickness from the top, because the material is going to be added on this side. And if we have an overall height dimension, need to remove some of that material. So we'll jump out, we'll jump into a revolve sketch. It's going to give me a warning, no big deal. I'm going to pick this as my axis of revolution. You can see that it's giving me this thin feature. So if I set this to 9 millimeters, you can see that it's adding 9 millimeters on the outside edge of my sketch, which is why I had to subtract those 9 millimeters from the initial height. And then it's adding all the material on the inside. So we have everything dimensioned the way we want. Go ahead and accept that there. From here, we're going to go ahead and create the sketch for our ribs. One thing that I like to do in these cases to make sure that, generally at least, I don't have any problems with having not enough material. In this case, if I just extrude it up from this circle, I'd have to go in and delete the little face that gets created. So I'm just going to select the inside wall, and I'm going to do an intersection curve. So it'll give me the point, or the circle, where that conical face intersects the plane that I'm working with. Then same thing here, I'm going to use a mouse gesture to convert that entity, and then I'm going to start by drawing some lines to create my rib, and then I'm going to trim away the excess. Then from here, I'm going to dimension the rib width, which is 6 millimeters, and then make these two line segments equal length, and that'll give me a horizontal rib there. So then when we exit our sketch and extrude this up, double click that surface to be offset from that, or to go up to surface, but then we can also modify that to be an offset, and by hitting the tab key, we can go ahead and punch in our value of 2 millimeters. So again, that rib's going to come up, it's going to be offset from this by 2 millimeters. Then we can go ahead and create one of our inside ribs as well. So we'll go from the front plane, same thing, intersection curve here, just to get that inside edge. I'm going to go ahead and delete that portion and create a line. So horizontal line, go ahead and pick up the parallel relationship here by hovering over it, and then this actually terminates early, so we'll go ahead and pick up this bottom line and that to get our 30 millimeters from the floor. And then our rib thickness is, if I remember right, yes, it was dimensioned by the diameter here. So we're looking at 65 millimeters, or 65 divided by 2, so we're getting a radius dimension. Then I just have to trim this little bit away, and now I can jump right into extruding from the mid plane by 5 millimeters for the rib. Alright, so now we have one of each rib. Now we just have to circular pattern both of them. So let's start by circular patterning this feature here. We'll do it around that axis, and we'll do it 6 times. Hit OK, and then I can hit enter to bring up the same command again, and then I can just select that internal rib. Let me clear that selection, and we're going to pattern around that, grab that feature instead. Alright, and then we only need to do this 4 times. Done. Alright, so now we have all of our ribs in place, and we can set our material to ABS, not PA, ABS, there we go. And we can pull up our mass properties, and we're right on the money at 659.7. Hopefully you learned something there. Again, the thin feature is a good, it's a good use case here. You could also do an offset within your sketch, and then you have a complete closed circle or a closed profile. That saves you the issue here where you had to subtract the height. So again, you could create this outside, this single line that I created, and then offset that 9 millimeters and dimension to the top. You can also save that step by just doing a thin feature extrude, and then just pulling in the right features, so we have a complete rib that goes all the way up to there. Alright, hope you learned something, and stay tuned for more.